This is awesome. I have not done an in-person event since 2019. As you can imagine, a lot of speakers out there have been doing virtual events all this time, and it's a pleasure to be back in front of an audience and speaking to real people and networking and hearing all the enthusiasm, and really excited to be here. So thank you very much for coming to my talk. So my talk today is building optimized Java microservices with Micronaut and GraalVM. I don't know if any of you, show of hands, any of you in the audience heard of Micronaut? Few hands. Okay, good. GraalVM? Few more hands. So, okay, so these are relatively new technologies, right? I'm an architect working at Oracle Labs on these technologies on a daily basis. So I'm kind of in the world of Micronaut and GraalVM, but I know there's a whole, plethora of people out there who are not familiar with these technologies yet, and it's my job to get you familiar with them. So I don't have a lot of slides on this subject. I have a few slides. For those of you who have been to a presentation by me in the past, I'm not big on slides. There's going to be a lot of live coding demos in this talk. I hope you get have a good takeaway from an example of what can be done with these technologies from the live coding demos. But I will provide you with references and links and tutorials and so forth to take away. So in terms of an introduction to the Micronaut framework, Micronaut is I guess, relatively new. Kind of late 2018 is when we went 1.0, but with these technologies evolving, it's relatively new compared to some of the competitors, and it's focused on modern architectures. This is true, so serverless workloads, microservices, that kind of thing. But it's also really a general purpose application framework. So much like Spring or that kind of thing. The only main difference between Micronaut and something like Spring, I'm sure a lot of you maybe are familiar with Spring, is that it does most of the processing at compilation time. So it works through Java annotation processing. It hooks into the Java-C compiler directly. And this provides a number of benefits because we do a lot of the analysis of the way your application works during the compilation phase. And we're able to type check and assert that your application is correct before it starts up. So, Micronaut, like something like Spring, is based on the use of annotations. So we type check a lot of those annotations. We type check the usage of the framework. And we build an optimized application that eliminates some of the kind of common things that make frameworks complicated in Java. So Micronaut doesn't use things like Java reflection. It will essentially, during the compilation phase, compute all of the method handles, and it needs to, for example, perform tasks like serialize and deserialize JSON or invoke your code. There's also no dynamic class loading in Micronaut. So like in a traditional framework that's based on servlets and Spring and so forth, there's very complex class hierarchies for class loading. None of that exists in Micronaut. There's just the system class loader. And a lot of the reason for this is to optimize performance, make it as efficient, fast, quick as possible to start up, and provide a really productive developer environment for building applications. It has a HTTP, by default, kind of most commonly used combination is an HTTP client and server based on the Netty IO toolkit. But Micronaut is usable beyond just Netty, because it's a general purpose application framework. So there's actually people using it, for example, to build command line applications, to build even desktop applications with JavaFX, using it to build message-driven microservices with Kafka, because it is essentially a general purpose programming model based on annotations with features like dependency injection, configuration injection, interceptors, et cetera, et cetera. So to find out more, Micronaut.io is the website. GitHub, it's all open source, it's all Apache licensed. And it has a great relationship with GraalVM. So Almost 2 years ago now, I joined Oracle and Oracle Labs and the GraalVM team because of the very tight synergy between Micronaut and GraalVM. So GraalVM is a relatively new virtual machine out of Oracle Labs. And it has the ability to plug into the regular Java virtual machine, or JDK, via the JIT, and increase application throughput between 20 and 30%. You have big companies like Twitter and so forth that are using GraalVM and the JIT to improve their performance. But it's also able to compute applications into self-contained native binaries. It's able to essentially analyze a regular Java application and compute what's called a native executable that's specific to that platform. And it does so by performing a closed-world static analysis of your Java code base. So that's what it's most commonly known for, native image and computing native binaries. But it's really much broader. It has, for example, the Truffle language framework. And there are implementations on top of Truffle for JavaScript, for Ruby, Truffle Ruby, Python. So it's a really broad set of technologies. But Micronaut and GraalVM work really well together, which is what I mentioned before. They're essentially a match made in heaven, and that's because in order to compute a Java application, a JIT-based Java application into a native executable, GraalVM has to perform a closed-world static analysis on the application. So it has to analyze the application and find all the reachable paths and figure out how exactly the application works. And because Micronaut doesn't use any reflection, any dynamic class loading, any runtime proxies, any bytecode generation that exists in traditional frameworks, it's much easier for GraalVM to perform that analysis. And once you've computed your application into a native image, startup time is super fast, memory consumption drops, which makes it really possible to use Java in scenarios that weren't possible before. So we have users of Micronaut and GraalVM, for example, deploying to serverless platforms. We have folks deploying to IoT devices, low memory footprint IoT devices. In cases where a JIT or a Java virtual machine, the existence of the entire Java virtual machine would just get in the way. The native executable is able to run in a much smaller memory profile and start up a lot faster. So it opens up a whole world of possibilities when writing Java applications that didn't exist before. So like I said, I tend to do a lot of demos. So I'm going to get jumping right into demoing. And I have over here Visual Studio Code. Now, Micronaut has great integration with IntelliJ and other IDEs. But at Labs, we also have a team, Oracle Labs, we also have a team building fantastic Visual Studio Code tooling. And I work with that team on a day-to-day basis, giving them advice on how this tooling should work. So it's one of the most awesome things about working at Oracle and Oracle Labs is that I can essentially work with this team and then demonstrate their work in an event like this. So one of the things they built is like Micronaut tooling for Visual Studio Code and GraalVM tooling. And you can install it via the extension marketplace if you search for, I think it's the GraalVM extension pack. So you go to the marketplace and you search for GraalVM, you got the GraalVM tools for Java. And if you install this extension, which is from Oracle, you will get all these great tooling. And one of those things is the Micronaut tooling. So you get presented with a quick start way to start building applications. And so I can immediately go here and click and start creating my new application and get to pick the Micronaut version that I'm using. Now, the way this actually works is it communicates to the backend start.micronaut.io website. So if you don't want to use VS Code, you can also go in your browser and go to start.micronaut.io and start building your application straight away. So you can choose your kind of application you want to build, the Java version you're targeting, the build tool you're using, the testing framework you want to build, and you can click the Generate Project button And then you can choose to download a zip file of that project or push the code directly to GitHub and start developing straight away. So I, as a developer, can get going like straight away. But in this case, the team working on our VS Code tooling has built direct integration, so I can basically choose directly through here the GraalVM version I want to use to build, the project name, the package name, the language. Micronaut has support for different languages, Java, Kotlin, and Groovy. We're going to be sticking with Java. And then you can go picking your features. Now, Micronaut has integration with loads of different technologies. And there's a long list here of different technologies that Micronaut integrates with, depending what you want to do. I don't know, for example, if I wanted to send emails with Micronaut, there is integration with messaging, email systems from SendGrid to Amazon Cloud to Postmark to Mailjet, etc. If I wanted to integrate with Oracle Autonomous Database, we have modules to do that in Oracle Cloud. If you wanted to integrate with, there's Kafka. There's Kafka integration. So there's lots of different features that you can integrate with. In this case, for this demo, I'm going to start with just demoing Micronaut Data JDBC. And I'm going to create a project that uses the Gradle build tool. You could choose Maven if you're more familiar with that, and JUnit 5 as a test framework. And I'm going to create my project in this directory. And this will essentially initialize my project and import it into Visual Studio Code, where I can start developing straight away. Now, it'll take a little minute to kind of scan the project and get it set up. In the meantime, we can take a little tour of the project structure. So Micronaut itself, if you're familiar with something like Spring Boot or etc., is very similar. It's a Java framework. You have a source main Java directory where your Java code goes. You have a source test directory where your test code goes. There are source main resources where you'll find your logging configuration, you'll find your application configuration, and everything like that. In this case, I have a build.gradle where it defines my dependencies. If I had chosen Maven, there would be a pom.xml. And my project is immediately set up, and I'm ready to go. Now, one of the things you'll notice is that when we created a project, there's a strong focus in Micronaut on test-driven development and testing in general. So we have a test immediately created, and this test is pretty simple. All it does is test that my application can start up successfully, right? So it has a single method that tests my application can start up correctly. And in the source main Java directory, there's a single class, which is my application class, which is how I bootstrap my application, so how I start it up. So I can click here, for example, and my application will start up, and I'm up and running as a developer. There's also a way to basically run continuously. If I do that and run continuously, in this case, it will basically automatically restart the application every time I make a change to the code. So you get like hot reloading of your changes to your code automatically and things restarting. But I tend to not use that very much. I'm like very much a test-driven development kind of guy. So I go to my test, for example, and I run my test. And I check that everything works by making sure that I have lots of green ticks. If I have red ticks, then my tests are failing and I'm not happy. But essentially, yeah, I tend to work primarily in my tests. And one of the things that with Micronaut, by doing more at build time and doing everything during the build process, is that tests execute really fast. So this application is a kind of, when you add the @Micronaut test annotation to a JUnit 5 test, what happens is it actually bootstraps the whole of Micronaut inside the JUnit 5 test, and it lets you dependency inject components into your test itself. So I can do add inject and embed my in this case, embedded application and check if it's running. And this this is a full integration test, and it executes like super fast. And that's one of the things that we focus on in Micronaut is like we want to make sure, a lot of frameworks they start up slower, and then your tests you have to kind of mock out parts of it or mock out parts of your code because things are slow. We want to make sure everything is fast when you're using Micronaut, right? So from test execution to running your application, everything being super fast. So, I have a basic application here. It's not doing much at this point. It has a main method where I can start it up. It has a test where I can test it. So let's start building an application and see what it feels like to build a Micronaut application from scratch. So one of the things, and actually I want to make sure here that I'm using the, yes, I'm using the Java 17 version. So one of the things that I love about Java 17 is records. So I can create a new Java class here, for example. In fact, you don't even have to create a Java class. I can create a new record directly, and we can call it like person, for example. Here's my person record. And records in Java 17 are really cool. They're much more syntactically concise data carriers. Previously people in earlier versions of Java used Java beans and getters and setters. These are immutable types that include conciseness, but also can be used as data carriers, for different tasks, whether you're serializing objects to JSON or whatever. So, for example, I can create a person class here, record, and just provide some record components to my record, right? And then I can go into exposing this as a REST API from my microservice. So what I can do is I can go new from template again and create a person controller like so. And this can be essentially a web controller. So if you're familiar with something like Spring, very similar in the case of Micronaut, you can expose what are called controllers over HTTP. So I can say this person controller is exposed over the people URI. And I can do things like list the people, for example. And we can import that list, and we can say return a list of people to implement this really easily. There we go. There's my list of people being returned from my controller. And we can populate that with some data. So I can say, let's do Fred Flintstone, who's like 45 maybe. I don't know how old Fred Flintstone is. And Barney Rubble, there we go. And we're returning essentially 2 records from this controller. So how do I make this controller method exposed over HTTP? And again, that's a simple matter of just defining an annotation. So I can say this is exposed over an HTTP GET. And now I'm exposing the data from 2 records of an HTTP GET request. So let's see how I test this. Now I want to write a full integration test for my microservice endpoint. So let's go back over to my test here. And in fact, let's create a new test. Let's call it person test, for example. And we can annotate this with @Micronaut test to make it an integration test that's going to spin up my entire application, including the HTTP layer. And let's write a client for my microservice that communicates with this person controller. And the way you can do that in Micronaut is through interfaces. So I can say person client, if I can spell correctly. And I can say this client is going to talk to the people endpoint, like so. And Micronaut has a fully declarative HTTP client. So I can say, return me the list of records over HTTP, like so. And I can write a test for this, right? So I can say add test. This is a JUnit 5 test list people, right? And I want to use my client that I've just defined here that is an interface. And what we can say is just inject it into my method, my test method here. And let's do client.list all the people to get a list of people. There we go. So we have my list of people back from my microservice. Let's do an assertion on that data. So we're going to do assert equals. I expect there to be 2 people coming back. And replace that with a static import. And let's see what happens when with this result. So I'm going to run the test. Hopefully the demo guys are with me on this, which they're not. So I have an error. Oh, so this is interesting. So the error is that I'm calling list, and that's actually something we should catch at compilation time. So probably have an improvement we can make to the framework. But you actually have to tell what kind of HTTP request we want to make. In this case, we want to make a GET request to my service. So, but look how nicely in VS Code we have this surfacing of the error message. So let's run that again and see what happens. Okay, so my test is passing. So this is a full end-to-end integration test. And as you can see, it executes super fast. Yeah, I'm not waiting around. And actually, this particular application, because I chose the Micronaut data JDBC feature at the beginning, is actually spinning up a data source at the same time. And I'm still getting this feeling of being productive as a developer, being able to run my tests, or things being fast, right? And it's super easy to define servers, super easy to define clients, and everything is very slick. So, this, if you don't believe me that this is making a full end-to-end HTTP request, we can go into my logback configuration, for example, and I can define a logger in here. Let's define a logger, ir.micronaut http.client, and I can say this is level equals trace level logging. And we can go back to my test, and we can run it again. And we can see from the output now down here, you can see that down there, but basically you can see the JSON coming back from my client as the objects are serialized from the server back down to the client and back again. So pretty simple to set up a simple HTTP client server application over using REST and using and remaining productive. Everything is easy to do. Now, but that's not all. I mentioned, for example, type checking and compilation time checking and so forth, and that exists in all parts of the framework. So, for example, if I were to define another GET request here, where I want to find a person by their first name, string first name, for example, like this. And for the moment, I'm just going to return null because I'm not going to implement it for the moment. This is a common case where people get critical of the use of annotations or whatever in Java, because this is it's stringly typed. This you got a reference in here in my URI variable. For the URI, I have a reference to the first name property, and then this binds here to this first name parameter. Very convenient and a feature that exists in most frameworks like Spring and other frameworks like that. But easy to get wrong. And what's cool about Micronaut is the kind of active type checking. So if I made a mistake here and like named that incorrectly, which could lead to a confusing runtime error, that's not a confusing runtime error in Micronaut. It's a compilation time checked aspect of the framework. So it tells you that the route declares a URI variable called first nam, and there's no corresponding method argument present. So you get compilation time checking that you're doing the right thing with the framework, which is really helpful in general and a real differentiator with Micronaut over some of its competitors. So now let's think about like data access. So what can you do, and how does Micronaut integrate with databases and persistence and that kind of thing? So what you can do with Micronaut is, and I have already, for example, when I created this application, chosen to include Micronaut data JDBC. So you can see I actually have an in-memory database being set up for me in this project every time I run it. So I already have an in-memory database set up. So one of the nice things that with Micronaut data JDBC, and Micronaut data is a sub-project of Micronaut where there are different implementations. So we have implementations for JDBC, which is like low level, and is a simple data mapper. So it's like, I have this record and I want to map it to the results of the SQL query. That's Micronaut data JDBC, right? It's not an object relational mapping tool. Like we also have Micronaut data JPA, which supports JPA and is an object relational mapping tool. JPA is an object relational mapping tool. But object relational mapping tools have their overhead, and personally, I'm a big fan of like simple data mappers and just like SQL, and maybe it's because I work at Oracle, I don't know, but I like I like getting close to SQL, and I like Micronaut data JDBC because it's like I just want to say, I have this record, just bind the result set to this, to this record, and I don't want to think about things like lazy loading and n+1 problems and all this kind of stuff that you get with object relational mapping tools. So one of the things you can do with Micronaut data JDBC is simply map it to a result set. So I can actually annotate a record and with at mapped entity, and for example, I can define a ID in my record, and this can be a generated value, for example, and it can be the ID. And you can make it nullable to begin with. And now this record type is mapped to a table called person with a first name column and a last name and an age column, and with all that entails. So now, like I said, Micronaut data JDBC is not a norm. It doesn't support associations, lazy loading, but I actually prefer that, right? So it's a lot easier to work with, and you can map. The idea with Micronaut data JDBC is that you can map multiple entities to different views on your database or different queries. Like there shouldn't necessarily be a one-to-one mapping between, person and table. You should have, person only first name and last name entities and map that to just like the optimal result set that you want, right? And optimize your queries based on the data that you actually need. One of the problems with object relational mapping systems is it kind of leads people down the path to always retrieve all the data, like always retrieve everything from the table, right? All the data that I want, like the entire entity with all its columns and whatever. When a lot of queries just need like three columns, and people tend to not like do DTOs and correctly optimize their queries. And then obviously n+1 problems and all sorts of things. Whilst with Micronaut data JDBC, it's like, just get the data that you need, right? And what you can do is you can say, we actually have a Micronaut, I think in new from Java template, you can say Micronaut create a data repository interface from my entities, I believe, or something like that. Or maybe I haven't saved that properly. Anyway, it doesn't matter. I'll just do interface. OK, so what I can do is create a person repository, like so. And you can say this is a JDBC repository that uses a dialect of H2, and it extends from CRUD repository. And we're going to pass in the entity type and the ID type, like so. And CRUD repository is a super interface that basically allows you to perform CRUD operations. I can easily perform CRUD operations on this using this interface. And what we can do is inject this into my controller. For example, I can say private final person repository. And I'm a big fan of constructor injection, dependency-based dependency injection. I know a lot of people tend to do stuff like this, where they do a person repository and they do inject, and they inject the field. But that has a higher risk of null pointers, and it doesn't correctly. It kind of lets you create the controller without this, which I don't like. I think it's much more clear to express the requirements of your class using constructor injection and making sure that the constructor is present. And then we can use this repository to actually implement this functionality. So I'm going to make it, instead of just returning a hard-coded list, I'm going to say a repository that will find all. Now, one of the things with the find all method is that it returns a iterable, which my controller is actually returning a list. So one of the nice things you can do is easily override that. So I can say override method, and I can say find all. Oops. Override. What did I do there? Override method, find all, override it, and I can change it to return a list. So every single method from the parent type is customizable. There we go. I've implemented the functionality of this controller of talking to a database, and it was pretty easy. And I can implement this functionality as well, saying find by first name with my repository. And I can create that method in my repository. And if we look at the implementation, what will happen is with Micronaut Data JDBC is at build time, it will compute the SQL query to execute. So it uses the dialect that you define up here to, at build time, work out exactly what SQL needs to be implemented. And then you can also use your own SQL queries. So I can say add query, and if I wanted to get low level, I could say select star from person where first name equals first name, like so. And I can directly be in control of my SQL. I don't have to, there's nothing hidden. It just implements the logic automatically for me of converting the result set into person if I want to. Or if I don't want to, I can leave the framework to do that. And this is what we were talking about. I was talking about intelligence or compile time intelligence that it doesn't exist in other frameworks. So if I make a mistake in the expression language, like for example, there's other types of expressions I can do. I can say find by first name starts with, for example, or I can say contains, there's a whole bunch of different possibilities, and we actually have code completion coming. IntelliJ already has code completion for these methods, but and VS Code we have it coming in a release very soon. But if I make a mistake, you see how Micronaut is actively compile time checking what I'm doing. So the application won't run. It's saying, you've typed something, and I don't know how to deal with it. So I'm going to fail compilation at this point, right? And that's really important. We believe that compilation time feedback in frameworks like this is really important for developer productivity. And you can see that you get a compilation time error if you do anything wrong when you try and write a query. So I'm not completely without guidance here on what I'm doing. And with that, we have implemented the logic in our controller. Now it's just a matter of populating some data, right? So one of the things I'm going to do is I'm going to go over to my record, and records actually allow you to have multiple constructors. So I'm going to add another secondary constructor, which has just the properties of that I want, and where I can pass in a null ID to begin with, because it'll just make my life easier when I'm actually creating the data. So I think I need a semicolon. That's probably it. There we go. And what I can do in my application class now is create some data when my application starts up. So I'm going to add an annotation to this application class that makes it a component in my application. So Micronaut implements the JSR 330 specification for dependency injection. So you'll see a lot of Jakarta inject and at singleton. And I'm just adding this to my annotation, to my application class, so that I'm able to dependency inject. And I could have used any type, but I'm using this application class. But I'm going to be able to dependency inject now my personal repository into my application class. There we go. So I've injected it into my application class. And now I can set up some data on startup. And the way I'm going to do that is I'm going to define an event listener that is transactional, that's going to run when my application starts up. And it's going to listen for the startup event, like so. And when the application starts up, we're going to do repository.saveAll. I don't know if I think I might have not saved that. And we're going to import list. And we're going to save those two people. So we're going to say, I'm going to have to type it again. I should have saved it somewhere. There we go, Fred Flintstone and Barney Rubble, I guess. There we go. So when the application starts up, this is going to be fired. It's wrapped in transactional. So if I had other operations here, if anything went wrong, it'd be rolled back. Let's test it out and see if all these changes I made actually haven't broken my application in its entirety. Okay, so the test passed. You can see now from the data that I am essentially getting some IDs back from my database, right? So the inserts worked. I've built a fully, full database application that is a microservice. It's talking to a database. It's exposing web endpoints. It's exposing things over HTTP client server, and that's pretty cool how you can do that really, really quickly with Micronaut. And what's also very cool is how you can easily convert Micronaut applications into native images. So one of the things with Micronaut is you can take the application, and I'm just going to make sure I'm using the right SDK list Java, because sometimes the terminal gets out of sync with, let's see, with the Java version that I'm using. Okay, so one of the things you can do with Micronaut, one second. Okay, so we have, SDK use Java. Okay, right, it's Java version. Okay, I definitely have Java 17. Okay, so now to package a Micronaut application into a runnable Jar file, we can assemble it, and I think in Maven it's just Maven package. You could assemble it into a Jar file and package it up, and then you just do Java jar build libs all and run it, and my application is a runnable application that I can deploy to a container. Or, in fact, if you wanted to containerize your application, you can also do GraalVM Docker build, and that will package my application into a Docker container automatically. So we have dedicated integration with Docker and building Docker images out of the box. And probably with the Wi-Fi, maybe it'll take a long time to download the Docker image. But anyway, so I'm going to skip that for the moment. You can also do Docker push to push the container to container registry if you've set that up. But what you can also do is do GraalVM native compile. And if you're using GraalVM, which I am, this will essentially perform the closed world static analysis to convert the application into a native image. Now, the process takes some time. Performing a closed world static analysis and producing a native executable of a Java application is no small feat. So it actually takes like a minute or two to complete. What it's doing is going through your application, finding all the reachable points in the application, and essentially converting it into a native executable that's runnable only on this machine, which happens to be a Mac machine. We also have GraalVM Docker Build Native, where you can use a Docker container to build your native image, which you would typically deploy to production. So, but the point is, it's really easy and it's integrated into the tooling directly for the Micronaut framework. Building native images, creating native applications is a first-class citizen for Micronaut. It's part of the experience, and lots of people are doing it, right? So lots of people are creating native applications, deploying them to the cloud, deploying them to serverless. Using Micronaut for serverless. Speaking of serverless, I have another talk tomorrow, which I want to point out on multi-cloud serverless. With Micronaut and GraalVM. So if you want to see more serverless action and so forth with native image, do come to that talk. But essentially, you can build native executables from your Micronaut applications, and the advantage of doing a native executable, the kind of trade-off, AOT versus JIT, is you get significantly faster startup time with AOT. You get much lower memory requirements in your application, and it opens up the possibility to deploy an application like this, written in Java, that's using database, that's using complex applications to much lower memory footprint microservices, to containers on K8s, Kubernetes, to serverless environments, and so on and so forth. So, and another thing I want to point out is I don't have it set up in the demo, but in the latest version of GraalVM, there's also a quick build mode, which kind of cuts the build time in half, where it doesn't perform all the optimizations, but for like a development cycle where you just want to see the actual execution is quicker. So there you go. I have built my native executable, and you can run it. I don't know why I'm saying that, but okay, well, whatever. And you can see that the application startup dropped to 65 milliseconds. You can see down there, but the startup time is significantly lower. And if we look at the memory consumption of this application, it's 18 megabyte process, which, considering like the Java version, the JIT version would be about 100 megabyte, so forth, is a significant saving in terms of being able to run the application in different kinds of workloads. And I have a lot more to demo. I can keep talking about Micronaut. I had some backup plans here. to show you, for example, how you can take this application and make it reactive. So I had like an R2DBC data source, but I don't know how. Probably I only have like 5 minutes left or something. But basically, everything I've demonstrated so far is like using blocking, JDBC, Micronaut data JDBC, and blocking. But you can easily switch out the application as well to use Micronaut data R2DBC. And switch out the driver, essentially, to use the R2DBC driver instead. And when I do that, I can switch over my repository here to, instead of being a JDBC repository, to being an R2DBC repository, instead of extending CRUD repository to extend Reactive CRUD repository. And then I can switch my application over from using lists to Flux in Reactive terms and mono results. And if you're used to reactive programming and Flux and mono and all that, and optimize away all those imports, and I can switch my controller over here by changing the return type to Flux and changing the return type to mono. And now I have a fully reactive application, non-blocking. Micronaut is based on Netty, like I said at the beginning. And with just a few changes, I've been able to switch the programming model from synchronous blocking to reactive with Micronaut data R2DBC, which is another variation of Micronaut. So that was the demo. I hope you had fun having a whirlwind tour through all of Micronaut. If you want to get started with Micronaut, I recommend going to start.micronaut.io and creating your application. Use an IDE for sure. I'm using Visual Studio Code with the VS Code extensions, and they are awesome. As you can see, I demoed everything with VS Code, and these are the extensions we're building at Oracle Labs at Oracle, and they're getting better and better, and I'm super productive in them when I'm building Micronaut apps. But IntelliJ Ultimate also has amazing Micronaut support, including code completion for Micronaut data. Lots of things. You can check out the docs at docs.micronaut.io. There's lots of guides about Micronaut and cloud native and for different clouds. And you can learn more about GraalVM at the docs as well. So in summary, Micronaut and GraalVM are leading this revolution in the Java world towards doing more AOT. Where server-side Java is adapting to these modern architectures. And you can build really efficient low memory footprint applications with the right framework choices. Micronaut optimizes for lower memory consumption. And there's a trade-off with AOT. The compilation speed is longer, but it opens up possibilities that just weren't really possible before. And going native now is a reality with GraalVM Native Image. And I hope you enjoyed the talk. We do have an Oracle booth. So if you want to scan these codes, there's some free resources at the Oracle booth for Jay on the Beach, specific to you. And do please fill out our DevRel survey as well. We'd love to hear from you. Do scan these QR codes. And thank you very much for attending my talk. I think I have time, some time for Q&A, a little bit. But yeah, we'll open it up. Thanks a lot.
Thank you so much, Graeme. So it's really interesting to see how you can build applications with, cloud native applications using Micronaut and GraalVM. And we do have one question that we have time for.
Yeah.
And it is rather quick, actually.
Let's see.
So let you read it out loud.
The last one there. Yeah. So is Scala support planned? Actually, Scala support is one of our highest voted for feature requests. And yes, it is planned. I don't know if in the next year, but we do want to implement Scala support. We have a large Kotlin audience and a large Groovy audience as well, so we're aware of alternative languages. Certainly Java is the biggest, obviously, audience that we have. So yeah, it is planned. And we're kind of working on the compiler to make it more modular as part of supporting KSP for Kotlin. So hopefully the Scala support will emerge out of that work.
Okay, so we have something to look forward to other than lunch.
Yes, I'm sure you guys are all starving, so I won't hold you up much longer.
No, thank you so much for your talk. Let's give a big round of applause for Graeme Rocher.